Hello, sir. We are from Group 3. Our group member is me, Tracy Sambai Anak Nelson, Hyoro Zhao, Hao Han Ching, Ong Li Xuan, and Dugashidi Dewi. Our project title is Proposed Green Building Concept based on GBI Green Building Index Rating Tool. Malaysian buildings are graded according to a nationally identified green standard called the Green Building Index. Its goals are to encourage building energy efficiency, educate the public and professionals about environmental challenges, and emphasize our duty to future generations. The GBI rating tool gives builder and building owner the opportunity to plan and build environmentally responsible, sustainable building that can lessen the effect on the surrounding, save finance on energy and water, enhance indoor air quality, have easier public transportation access, and integrate recyclable material and landscaping into their development. Next, reducing waste. Waste management is frequently a component of sustainable building projects. Reusing material that might otherwise wind up in the trash is an important part of effective waste management. Waste management for sustainable construction projects must involve garbage reduction, recycling, and reuse. The most recent iteration of green building grading system now acknowledge the passive design concept. 5 common grading systems, each of which had its design standard that lead to the awarding of certain credit, were compared to determine how complete, effective, and correctly each criteria in the study was applied. Additionally, a full analysis of the effect of passive design factor on building energy consumption is given, including building geometry, airtightness, structure layout, envelope, thermophysics, and infiltration performance. The findings demonstrate that a true design strategy based on passive energy conservation technique is successful in lowering the building overall project. On the basis of additional sensitivity and parametric research, green building grading tools should, however, contain more unfit weighting method to enable comparison of various passive solutions. For abstract, the study conducted is about the proposed green building concept based on GBI Green Building Index Rating Tool. The basic method that been used for this project is using GBI assessment criteria for non-residential new construction. Moreover, result that been obtained was energy efficiency, indoor environmental quality, sustainable site planning and management, material and resources, water efficiency, and innovation total point. For research background, the background for this project is related to designing green hospital using the GBI hospital tool to design healthier, cooler, and brighter hospital. 19 September 2015, held at the Kuala Lumpur Convention Center. The hospital basic components are outpatient, diagnostic and treatment, inpatient area, and last but not least, medical support. For problem statement, some of the challenges occur when designing green building using GBI hospital tool are infectious disease beyond border or related to globalization, developing illness to facing design, geriatric elder care facilities, green material, sustainability, life costs, and last but not least, adaptable architecture. For design objective, the design objectives are for hospital design philosophies, the green architecture Elements which are applied are cost-effective, accessible, sustainable, safety, health and security, functional, aesthetic, and productive. Next, for hospital design approach. For design scope, the design scope are passive green design, for example, a cooler environment. For example, designing for the sun have standard, have detailed design. Next, bringing in the daylight, for example, element of daylight design and detailed design with deluxe. Plus, they have element of natural ventilation, for example, designing to bring in the fresh air and ventilation cooling.
Salam sejahtera and good morning, Doctor. My name is Surkashini Deviana Pumpan Bala, metric number AN200202, and now I'm going to present on Chapter 2, which is the literature review. So there are 3 subtopics, which is the first one is Sustainable Development Concept, Malaysian Approach for Sustainable Development, and also Green Building Rating Tools. Definition of Sustainable Development. The term Sustainable Development was first used in the wake of the Brundtland Report, which described sustainable consumption in industrialized countries. The Brundtland Commission published its report in an effort to make connections between the problems of environmental stability and economic growth. In addition, sustainability can be defined as a broad conceptual framework that describes a desirable, healthy, and dynamic balance between human and natural systems. Sustainable development is based on 3 basic pillars: social, economic, and also environmental consideration. Basic pillars of sustainable development. Social sustainability. Social sustainability advocates for ensuring that future generations have comparable or even superior benefits to the current generation in terms of quality of life. Economic sustainability. Economic sustainability refers to making choices that are as fair and financially responsible as feasible while taking other sustainability factors into account. And the last one is environmental sustainability. Environmental sustainability attempts to promote growth and equilibrium within natural system. Environmental disturbances should be avoided whenever possible to maintain environmental sustainability. And then is the importance of sustainable development. A strategy for economic growth that doesn't jeopardize the environment's quality for future generations is known as sustainable development. Goals for sustainable development are to develop a set of global objectives that address the pressing environmental, political, and also economic concerns our world is facing. The second subtopic is Malaysian approach for sustainable development. Malaysia, like any other emerging nations, must balance economic development with environmental protection. The nation of Malaysia is ranked as the 38th most environmentally sustainable out of 146 countries overall and the second most environmentally sustainable in Asia, according to the 9th Malaysia Plan or 9MP, which claims that environmental sustainability has always been given due consideration in Malaysia. It is encouraged that management of rural and squatter regions be incorporated into environmental programs. Like many other developing nations, Malaysia must strike a balance between environmental conservation and economic growth. And the last subtopic is Green Building Rating Tools. The GBI rating tool offers property developers and building owners the chance to design and build environmentally friendly sustainable structures that can offer a healthier indoor environment, better accessibility to public transportation, the adoption of recycling and greening for their projects, and help minimize the environmental impact of construction. Evaluation of a project's sustainability has become essential due to sustainability's rising popularity in the construction industry. A building can incorporate sustainable design concepts and turn performance assessment into a tool that can be utilized for comparison using a variety of resources. The Building Research Establishment Environment Evaluation Method, one of the first and most comprehensive assessment techniques, was created in the UK in 1990. BREEAM. The primary objective of this assessment approach is to evaluate building specification, including their design and design, construction, and use. And that is all from me. Thank you.
Good morning, Doctor. My name is Han Cheng and my matrix number is AN200211. And now I'm going to proceed and explain about the Chapter 3 Design Approach. First of all, I would like to explain about the GBI, which is Green Building Index. GBI actually is an environmental rating tools for building, and it evaluating environmental design and Malaysia buildings performance. Normally, it is used as a standard guideline to identify the present and absent green building sub-elements of the research object. In this project, we are using the non-residential new construction as our rating tools. Then we will start with the energy efficient first. The first design we propose for the hospital is in the assessment of lighting zone, where we like to change all the lighting into the LED system because of its durability and minimal heat emission. After that, we also plan to install a single switch in all individual spaces where all the switch will clearly marked so easily accessible to the building occupants. Then, the switch will also integrated with the motion sensor system, so that light will only turn on when the motion is detected and can minimize the energy consumption. Okay, last, we also have a daylighting strategy where we plan to install the window at the high places to bring in the light from the above to diffuse the light inside the spaces. Okay, the next design is based on the assessment of renewable energy, where we plan to install roof-mounted solar system. Okay, we plan to install active solar panels over 140 square of roof spaces. We plan to using the solar energy as the hospital's energy supply, where the solar panel can capture the sunlight and convert it to the alternating current. Okay, and we plan to install the utility iterative PV system as well, which can interact with the electric utility power system. This PV system can also gather the extra energy that the solar system produces and store it so it can be used in the future. Okay, the next design is for the e-verification. Okay, for this, we are designing that energy consumption of the hospital project, including the sub-meter reading, will be monitored and analyzed using the energy management system, which is EMS. This will enable the hospital to run more effectively and conserve energy and aids in finding way to adapt and enhance energy-saving technology. Okay, moreover, we would like to carry out the maximum demand limiting program within 1 year of practical completion. Okay, this can be done by determining which section use the most energy and altering its operation during the peak hours. After that, we are going to discuss about the design approach in the assessment of sustainable site and management. In this criteria, the first design is based on the assessment of site selection, where the design must give preference to the area that are not environmentally sensitive or have minimal ecological significance. Therefore, our hospital is built on the Sungai Petani, where the site selection was not outlined by the National Physical Plan or the Area Structure Plan and State Environmental Protection Zone or Forest Reserve. And moreover, it is 30 meters away from any wetlands and was not formally as greenfield land that is within 30 meters of mean high water spring sea level. Okay, then the next design is based on the assessment of earthwork construction activity pollution control. In this, we will designing and executing the erosion and sedimentation control plan based on sedimentation and erosion provision of the approved earthwork plans. In the sedimentation control plan, we will provide with the measure to avoid soil erosion caused by the wind or stormwater runoff, and it will also provide with the how to prevent the storm sewer or receiving stream damage or sediment and dust and other particular matter pollution. For example, it will provide with how to control the stormwater runoff rate to minimize the soil erosion and clean and remove sediment when 1/3 capacity of the inlet protective equipment is filled out. Okay, after that, the next design is worker site amenities. For this, we will designing and executing a site amenity plan for the construction personnel, and it will provide with the provision for the welfare, health, and the personal hygiene requirement of the workforce. Okay, for example, design water distributed for the personnel for drinking must be from the outlet that are not connected to the toilet or laundry facility to prevent the contamination. Okay, then the next design is in the assessment of public transportation access. For this, the design must give preference to the location that are within 1 kilometer of the current public transit system during the site selection process. Therefore, we are going to plan to locate the Green Hospital within 500 meters of at least one bus stop so that building occupants can easily access public transportation. Okay, after that, the next design is in the assessment of greenery and roof. For this, we are going to utilizing vegetation on rooftops to reduce the effect of urban heat island by providing shade and evaporation cooling, and it can lower the surface and air temperature as well. Okay, after that, we are also to plan to plant the trees in the place such as sidewalks, country yards, and plaza to provide shade. The shade can protect the patient from the UV rays. Okay, lastly, we are going to using the standard green limestone paving materials for the sidewalks, country yards, plaza, and the parking slots. Because the solar reflectance index of the standard green limestone is 54, which can reflect more heat radiation. Then, I'm going to continue the design approach for the water efficiency. Okay, the first design for the water efficiency is based on the assessment of rainwater harvesting. Therefore, we design the hospital with a gravity-fed system. We are going to design a gutter system that used for the harvesting the rainwater efficiently. Then there we also have a water storage tank that located below the gutter system and above the outlet. So the system is only using the gravity to distribute the water. Moreover, the water tank will also equipped with leaf separator and mosquito probing to prevent the sediment build up and flowing from the large debris. Okay. Then the next design is in the assessment of wastewater recycling. For this, we are planned to install the pharma filter, which is fully integrated on-site wastewater management. For this, it is designed that have an interval sieve system that is used to carry out the wastewater to the pharma filter system for the treatment. Then the wastewater that after the treatment under the pharma filter is clean and ready to be used for the irrigation and toilet flushing. Okay, after that, the next design is in the assessment of water efficient irrigation and landscaping. For this, we design to amend the soil of the landscape with organic soil amendments such as wood chips and peat moss, which can increase the ability to retain the water in the soil. Okay, after that, we are also to design to plant the native and additive plants for the landscape because they use less water than their counterparts. Lastly, we are also designed to using the drip irrigation to irrigate the plants since it is effective and water conserving because it can water the plants directly at the roots. The last design is about the metering and leak detection system. Okay, for this, we are designed to install a water submeter at the hospital to control and monitor the large water usage system. Okay, moreover, the energy management system is going to build with the submeter metering, where it can identify abnormal behavior of pipe and alerting the operator of the situation to work as a leak detection system.
Good morning, doctor. My name is Raja IN 200201, and now I'm going to proceed the remaining GBI criteria, which are indoor environmental quality, materials and resources, and innovation. The first GBI criteria is indoor environmental quality. Indoor environmental quality refers to the indoor conditions of a structure that have impacts on well-being of the occupants who inhabit the building. It is significant to understand and control the indoor environmental contaminant sources in order to resolve the unwellness caused by the low IEQ to the occupants. First of all, a green hospital is proposed to be designed with environmental tobacco smoke ETS control. To enhance ETS control, a strict smoking ban is actively implemented in the hospital. Smoking is strictly prohibited at every corner of the hospital area. Besides, a staff manual or employee training is provided to the treatment staff and nurses in order to create a healthy workplace. Lastly, no smoking signs are introduced and erected in the hospital area. A green hospital is associated with low levels of indoor air pollutants, for example, volatile organic compounds, VOCs, and formaldehyde. Low and zero VOC interior paint and coating are applied throughout the green hospital. Latex-based paints are used as more of them are low VOC. Besides, milk paint and chalk paint, which are absolutely natural and carries no VOCs, is applied in the hospital. The types of heating, ventilation, and air conditioning HVAC systems are installed in the hospital based on the need of hospital function to deliver fresh air and remove chemicals released into the atmosphere. HVAC systems help in controlling ambient environmental factors such as temperature, atmosphere humidity, airflow, and air filtering. A green hospital is proposed to be designed of mold prevention. Eliminating moisture is the most efficient technique to inhibit indoor mold growth. Routine maintenance and inspections on all the equipment in the building, including the HVAC and plumbing. Desiccant rotor dehumidifiers are placed in the areas of the hospital to ensure the lowering humidity and prevent rapid mold growth and reproduction. A green hospital is proposed to be designed with high air change effectiveness. An effective ventilation system offers efficient air change that mitigates the short-circuiting and of recirculation supply and removes stale air rapidly to provide fresh air to the occupants in the green hospital. The application of the HVAC system achieved the 95% of air change effectiveness (ACE) in the accordance with Area 126/1997 for 90% of the net lettable area in green hospital. A green hospital is designed to fully implement the daylighting design into the interior of the hospital. To enhance the natural lighting system in a green hospital, the design of transparent and glazing facades is implemented in the interior of the green hospital to enable sufficient natural light to enter the spaces. Similarly, the installation of skylights with transparent paints and calming hues is done to improve the daylighting design in green hospital. A green hospital is proposed to be designed and maintained at an allowable and satisfactory internal noise level. Solid core doors are recommended to be applied in the green hospital due to the acoustic properties that help to insulate the outside noise. Aside from the solid core door, ceiling tiles with high sound insulation performance are implemented in the green hospital to control the nuisance caused by the ceiling-mounted services. The next GBI criteria is materials and resources. Materials and resources refer to the building materials that accommodate both new and recycled materials meant to utilize in the construction of a structure, and their performance affects the structure's performance. A green building that implements sustainable construction tends to mitigate the devastating impact on the environment, as green buildings encourage the use of green materials and environmentally friendly ways in construction. A green hospital is constructed using building products that incorporate recycled contained materials. To enhance the sustainable construction of the green hospital, the strategy of using recycled contained materials is implemented in green hospital construction. Rubber is one of the renewable and sustainable materials that can be cleaned and maintained with the absence of harsh chemicals. Due to its environmentally friendly properties, rubber is one of the favorable options for flooring material used in hospital construction. A green hospital is tending to use sustainable timber as one of the construction resources during the construction stage. Timber is one of the most environmentally friendly available building materials because it is natural living materials owns renewable and refurbished properties. Engineered wood products such as cross-laminated timber (CLT) and structural composite lumber (SCL), like laminated veneer lumber (LVL), are proposed to be applied in the green hospital construction because they are able to offer powerful strength and dependable quality. Aside from the properties of being highly reliable and sustainable, one of the finest aspects of timber is the predictable fire resistance level. A green hospital is designed to be able to facilitate minimizing the generation of waste that is transported and disposed of in landfill. According to the requirement released by the GBI, a green building is capable of providing permanent recycling bins during building occupancy. The recycling bins are provided at every corner of the green hospital in order to strengthen the implementation of the collection of recyclable. Besides, the location of the recyclable storage is designed as an ample space like the basement, as so the collection process is within accessible reach of the green hospital. A green hospital is proposed to be designed with the application of ecological sustainable refrigerants and cleaning agents. To meet the compliance with the GBI, non-synthetic and natural refrigerants for the HVAC system as well as the cleaning agents for firefighting with negligible ozone depleting potential and global warming potential are utilized in the proposed hospital. The most widespread natural refrigerants applied in the HVAC system are carbon dioxide and hydrocarbons such as propane. The next GBI criteria is innovation. According to Omics International, green innovation refers to innovative ideas, devices, processes, or approaches that deviate from standard traditional building methods to achieve sustainable development. Innovation acts as superior solution to address brand new demands, outline ones, or current market demands. A green hospital is proposed to be designed with all possible innovation ideas during the early design concept phase. The interior atmosphere is improved by the heat recovery system, which is a ventilation system that employs an air-to-air heat exchanger to recover the lost heat, meanwhile also delivering fresh, highly filtered air. Heat pipe technology was applied to develop an energy-efficient ventilation system and to guarantee that the mixing in the inflow and exhaust dust was not contaminated. Natural ventilation systems such as the courtyard and wind tower provide high airflow with minimum energy consumption. This ventilation system is generally practiced in Malaysia as an affordable alternative. The installation of no-flush urinal system assists in water saving and water conservation. The central pneumatic waste collection system encouraged to collect the waste through a series of vacuum-type underground pipes and then transported to the collected waste to a sorting facility. Waste segregation is done at the same time. The electrochromic glaze facade enhanced the energy efficiency of the fully glazed hospital, while enabling the windows to remain clearer for a longer period of time. The GBI facilitator is the key factor in assuring the stages of the green hospital construction meet the requirements of GBI. As a result, at least one GBI facilitator is assigned to the project team as early as in the concept design phase and ensure to stay on board for the entire duration of the project in order to assist in the development and construction of a green hospital that meets the condition of GBI. And that's all for Chapter 3. Thank you.
Good day, Doctor. My name is Ong Le Shen and I will present about the fourth topic, which is result and discussion. And in this topic, we will talk about the assessment criteria, specifically for the overall point score, the GBI classification, and also the project cost estimation. And here is the overall point score for the Green Building Index assessment criteria. And as shown in this slide, there are 6 criteria include energy efficiency, indoor environmental quality, sustainable site planning and management, material and resources, water efficiency, and also the innovation. Analysis of GBI assessment point score. Energy efficiency EE. According to the GBI assessment, the survey location received a total of 25 out of a possible 35 points. This indicates that the building used less energy to complete the same activity and thus emit lower greenhouse gases. Indoor environmental quality EQ. For the Aman Jaya Specialist Center, it scored only 14 marks out of a total of 21 marks. Hence, it is advisable that the developers take more concern in improving the indoor environmental quality of the building. Sustainable site planning and management. Based on the overall point score, this assessment criteria obtain a total of 9 marks per 16 marks. The stormwater management specifically needs to be improved at the survey location. Material and resources. The point score for material and resources is 8 out of 11, which is deemed to be fairly satisfactory. The material used is durable, reusable, or recyclable and natural. Water efficiency. According to the GBI assessment, water efficiency acquires a perfect score of 8 out of 10 marks. It represents that there is an implementation of efficient practices and technologies in the hospital to minimize the water consumption. And lastly, innovation. Based on the GBI evaluation, 5 marks out of 7 are awarded for the innovation part. It denotes that the building is using some of the innovative technology that is environmental friendly. Green Building Index Classification. According to the GBI assessment, we can conclude that out of total of 100 points in the rating system, the Aman Jaya Specialist Center score 69 marks, which lies in between the range of 66 to 75 points, and it is classified as a silver rated building. So by scoring well in these key categories, the structure will probably be more environmental friendly than those that don't. Project cost estimation. The construction cost consists of total building costs, basement car park, earthworks, infrastructure costs, and also the green building financing. By adding all of those costs, the total construction cost is 149,198,000. And for the development costs, which include professional fees, administrative fees, plan fees, legal fees, and also the contingency, the total development cost is 28,102,560 ringgit. Next, the utilities cost, labor cost, and repairing costs for over 20 years. The total utilities cost is 81,900,000 ringgit. The total labor cost is 65,460,000 ringgit, and the repairing cost is 5,400,000 ringgit. Total operating and maintenance costs for 20 years, which includes utilities costs, labor costs, and also repairing costs, is a total of 152,760,000 ringgit. Summary. The total for the combination of construction costs, development costs, and operating and maintenance costs is a total of Rm 330,060,560. Conclusion and recommendation. The research goals of this study, which is to suggest design approach for green hospital and make an evaluation of green building design according to Green Building Index, have been successfully attained. Conclusion. The Aman Jaya Specialist Center's potential and design strategy for applying GBI criteria have been successfully identified. The Aman Jaya Specialist Center rating levels were determined after adding all the points, and it was determined as a silver rated building. Higher certified buildings have demonstrated that GBI framework can produce buildings with better energy efficiency and maintain their green attributes throughout the majority of their lifespan. There are several limitations of study includes the project must be finished by a certain date and there is a time constraint. And secondly, the project might not receive enough finance. And third, the absence of fundamental understanding regarding to the green buildings. Last but not least, the recommendation. Further research should be done to ensure that improvement tools for other GBI criteria. The system can be made more efficient by requiring features of the grading tool, raising building designers' awareness and incentive, and other measures. The GBI framework might be modified to encourage the use of tropical architecture. And that's all from our group 3. Thank you for watching.